Hi guys, I have a limit to share with you. Yes, this limit, you can solve it by two different methods. The first one, L'Hopital rule, and just remind you by L'Hopital rules. Yes, L'Hopital rule, if you have rational function and the numerator and the denominator, when you substitute by x equal to c is 0 over 0, which is undefined value. So you can differentiate the numerator separately and differentiate the denominator separately. So if you substitute by x equal to c and you still have 0 over 0, you can do the same thing again. So you have f double dash of x over j double dash of x and substitute until you get a defined value. The other method using the special limit for sine x over x when x tends to 0, which is equal to 1. Let's go and try this special limit sine x over x when x tends to 0 equal to 1. So I don't have x, but I have 1 over x inside the sign. So I turn everything in terms of 1 over x. So I substitute, I divide it, sorry, by x squared. So I have 1 over here, x squared over x squared is 1. 2x over x squared is 2 over x minus 1 over x squared. Good. Now, yes, I substitute 1 over x by y. So I remember when x tends to infinity, y equal to 1 over infinity, which is 0, right? Okay. So the limit changed into y tends to 0. 1 over x is y. 2 over x is 2y. 1 over x squared is y squared, right? So yes, I take y as a common factor. Yeah, I remind you, yes, in this case, forget about the sine y for a little while and take 1 over y times 2 minus y and use the partial fraction. Yes, I have a multiplication of first degree terms. So I have a constant over the first one plus another constant over the second one. How to get a and b? In a simple way, you just hiding this one and both, which make it 0, which is y equal to 0. So when you substitute, you have 1 over 2 minus 0, so it will be 1 over 2. To get b, you just hide this one, right? And but what make this one is 0, which is y equal to 2, and hide this one, so you have 1 over 2. B is also 1. Now I split this one and I get back the sine y. So I have a over y sine y plus b sine y over 2 minus y. Okay, a is half, b is half. Now this limit, sine y over y into 0, yes, using this special limit, right? Okay, so I have, yes, I have half times 1. And I have, when I substitute by sine 0, it will be 0. Y 0, 2 minus 0 is 2. So I have half times 0 is 0 over 2 will be 0. So I end up with half plus 0, which is half. Okay, let's go and check the other method and we will have the same answer or not. Before I leave, don't forget 1 over infinity is 0, sine 0 is 0. Okay, let's go for L'Hopital rule. Yes, when I divided by x squared and substitute by x tends to infinity, so I have sine 0, which is 0. I have 0 minus 0 is 0. So this is undefined value, so I'll go for L'Hopital rule. Okay. Now, I have to differentiate the numerator separately and the numerator separately also. The derivative of sine is cosine for the same angle. The derivative of the angle, 1 over x is minus 1 over x squared. The derivative of 2 over x is minus 2 over x squared. The derivative of minus 1 over x squared is minus 2 over x cubed, and minus minus will be plus. Good. Now, if I substitute by infinity, so I have cosine 0 times minus 1 over infinity, which is 0. Okay. Yeah. But if I do this one, I have minus 1 over, yeah, over minus 2, which is half, right? Yeah. When I here, if I multiply by x squared, yeah, so I end up with what? Here I end up with minus 1, and here I end up with minus 2, and here I have 2 over x. So when I substitute, I have cosine 1 over infinity, which is 0, cosine 0 is 1, times minus 1 is minus 1, minus 2 plus 2 over infinity is 0, it will be minus 2. So I end up with half. Yes, I have the same answer. Again, don't forget, 1 over infinity is 0, cosine 0 is 1. See you in another video. Thank you.